All right, guys, so today we're going to go ahead and continue our notes from yesterday. Yesterday we were talking about exponential growth and decay. Today we're going to be talking about compound interest. First of all, what is compound interest? Compound interest means that it's interest paid or earned, that it's checked at different rates. Earned means that it's like a savings where you're investing in stocks or putting your money in savings at a bank, and they're going to give you money based on leaving your money in their account. So they're giving you extra money. You're earning more money as interest. If you're paying it, it's like borrowing money. When you buy a house, you have to pay that loan off, or a car loan and things like that. When I say different rates, when you have a house loan, and you can talk to your parents about this, you have to pay it monthly. So they are actually charging you a specific rate, and then you have to pay each month based on that rate. We also have money where you're earned. Most stocks or savings accounts will actually pay you quarterly, 4 times a year. So we need to talk about the different cycles. That way you understand how this all works. So we have annually, which means 1 time a year. They will pay you at the end of that year that full percent that you've earned or that you owe. Semi-annually means twice a year. That means you're going to be getting that money at the end of 6 months, and then you'll get another money at the end of the following 6 months. So basically they'll check it twice a year. Quarterly means 4 times a year. Every 3 months you will get a portion of that interest, or you will have to pay a portion of that interest. And monthly is 12 times a year. I will admit that when you are investing money, quarterly is the most common. They will give you a statement and give you your reflection on your money every 3 months. If you owe money, again, it's going to be based on monthly. You will have to pay that money once a month. All right, so let's go ahead and see how this works. Maria's parents invested $14,000 at 6% interest per year. It was compounded annually on this first example. Again, if you want to pause the video, you can actually write all this down. That way you can concentrate on listening when we're actually ready to go over it. So you can pause the video until you guys are done copying the notes, and then we'll go over this. All right, so let's go ahead and look at the equation. So it says that our beginning value is $14,000. They're starting with $14,000. Then it says the rate of change. How much is it changing? Remember, it's 100% of that $14,000 plus 6% that they're adding into that interest, okay? You're earning more money, so they're gonna add that 6%. Well, just like we did yesterday, what is 100% plus 6%? 106%. But we don't normally work with percents, so we're gonna convert that to a decimal. Remember, all percents are over 100, so when you move that decimal or divide it by 100, you get 1.06. Remember, 1.06 is the same thing as 106%, okay? So our actual equation for compounded annually, 1 time a year, you get that whole percent, is this equation. Now, if I want to find out how much money would be in the account after 10 years, I would actually have to plug in a 10, just like we did yesterday. That's our cycle, so we know that it's after 10 years. 10 cycles have passed. So we're going to plug that 10 in, and we should have $25,071 and some change at the end of those 10 years. So it's not a bad investment. Now, I want to explain, that one's not so bad, but I want to show you how it changes it when it's compounded quarterly. So let's do the exact same problem, but this time we're going to compound it quarterly, which means how many times a year? There are 4 quarters in a dollar, so there are 4 quarters in a year. 4 times a year. Now here's the tricky part. We know, again, that it's still $14,000 as our beginning balance. The rate of change is a little tricky because it's not the full 6% each quarter. It's 6% for the year compounded quarterly, 4 times a year. That means of that 6%, they are getting a portion of that 6% every quarter, an equal portion. So let's take that 6% and think about it. How much would they get if they broke it up into 4 quarters? Okay? You can try to find that by saying 6% divided by 4 cycles. Well, 6% divided by 4 is 1.5%. So they get 1.5% the first 3 months, then they get 1.5% the second 3 months, 1.5% the third quarter, and then 1.5% the last quarter. That adds up to the full year's percent of 6%. So when we're talking our rate of change, we actually have to think about it's not the full 6%, it's actually going to be 1.5%. Let's go ahead and convert that to a decimal. 100% plus 1.5% is 101.5%. As a decimal, that would be 1.015. Now, let's also talk about the cycles, our X value. If I'm talking about 1 year, how many times have they checked my money or given me that interest? They've checked it 4 times. So really, this is going to be 4 times every year. You're not talking about just the number of years, you're talking about the number of terms or cycles. So let's do that over here. If they are checking, if I want to know how much I have after 10 years, if they check it 4 times every year, in 10 years, they would have checked it 40 times. So they've checked it 40 times. So instead of just plugging in a 10, we're actually going to plug in a 40 to our equation. Let's go ahead and type that into our calculator and see what we get. I'm going to change that so I don't have to rewrite the whole thing. Again, you need to be making sure that you're typing these into your calculator. Make sure that you're getting the same thing that I am, because it could just be a calculator issue. So 14,000, parenthesis, 1.015 to the power of 40 should be 25,000. Let's write that down, $25,396. And 26 cents. Don't forget that money is always to 2 decimal places. So I want to compare that to what it was annually. Remember, annually it was 25,071. This one is 25,396. So it's a little bit more. Remember, you're actually having, just like we were looking at that T-table yesterday, you're actually earning more percent on that money because they're actually putting, after 3 months, they're putting in that interest that you've earned. So on the next cycle, you will be earning interest on more money because you have more money now in the bank. So that's why you actually will end up getting more. So you actually want your money compounded as much as possible because they're putting more money into your account. That interest gets put in every 3 months versus every year. Okay, so let's do one more. And this time I'm going to do it side by side because I want you to see the annual interest and the quarterly, just to show you again the difference between each. So again, our equation is always y equals bm to the x power. Let's read our example. Brooke is saving some money for a trip that costs $295.99. She puts $150 into a savings account that pays 7.25% annually. Remember, that's once a year, so we need to see what will it be at the annual rate. So they get the whole 7.25% one time a year. So our M value would be 100% plus that 7.25%, or 107.25%, which is 1.0725. What was my beginning money that she put in? 150. Now, I need to see how many times will my money be checked. If it's annually, again, it's one time a year. If I want to see how much she has in 4 years, one time a year, that means they've only checked it 4 times at the end of each year. So we would put a power of 4 there. and we can actually see how much we have. So type that into your calculators and let's see what we get. I got $198.46. She would not have enough money to go on her trip in 4 years. So she might have to start saving some more money if she needs to. So let's go ahead and finish this same problem by doing the quarterly. Again, our value this time, our yearly percent is 7.25%. So that did not change. What does change is how many times they're checking our money. So we're going to take that percent and we're going to divide it by how many cycles they are checking it, which is 4 times a year. When you do that, 7.25% divided by 4, you get 1.8125%. That is how much money they earn per quarter. So remember, let's write our equation. Our initial value is still 150. What is our rate of change? It's 100% plus that 1.125%, which gives you a total of 101.8125%. Let's convert that to decimal. 1.018125. What a big number, yuck. Now, how many times will they check her money in 4 years? It's not just a 4. This time they're checking it 4 times every year for 4 years. 4 times 4 means that they've checked it 16 times. Let's type that into our calculators and see what we get. And I get $199.94. Now I know it doesn't look like it's that much difference, but all she put in was $150 also. So the more money you put in, the more you're going to earn interest on. Okay? So that's kind of how that works. So I want to summarize this. And at the top of your paper, I want you guys to go ahead and summarize this with me. When you are compounding, it's still the equation y equals bm to the x. Now, if you're compounding it, you're actually taking that percent. Remember, it's 100% plus or minus, depending on the decay or the growth. If you're adding money, you add it. If you're subtracting, if it's a decay, you would subtract that percent. Now, it's the actual percent that they tell you for the year divided by the number of cycles. If it's semi-annually, it'd be divided by 2. If it's quarterly, it'd be divided by 4, and so on. Now, for our x, it's just the opposite. Instead of dividing, you are actually multiplying your number of years by the number of cycles. Okay, so one is getting divided, the other is getting multiplied. And then you would have your initial value. Or beginning value, whatever you want to call it. Okay, so again, we will practice some more with that. Do the best you can, and we'll see you guys when I get back on Monday. Thank you.